Hello everyone, JavaMentor.net here. In today's video, let's learn something about multithreading. This will be an introduction to multithreading, just to explain what's all about multithreading, what's happening there. I guess that you already know that modern computers, they all have multiple CPUs. For example, your computer might have 4 CPUs or 8 CPUs or something like that, which means that your computer can perform multiple operations in parallel. So one processor can do one thing, another processor can do another thing, and so on and so on. Maybe I should also say that in modern CPUs, one CPU can also do parallel things. So let's say up to 16 or 32 parallel things inside one processor. Why am I saying all of this? Well, I opened our old code without Gradle. So you remember we used to start our application using a main method, and we click run here and application executes. But in this fashion, only one CPU can execute all of those commands. So one CPU start executing this line, then this line, then this line. So one CPU is doing everything. It goes line by line, but everything is done by one CPU. Other CPUs are just idle, they are not used. Now, when we use Spring is under the hood using multiple threads. So every request that our application accepts, every request is handled by a different thread, but we don't see that. Let's try to explicitly create multiple threads, and I'll show you one problem that can occur in multithreading, the most known problem called raised condition, and you will realize what's happening. So I created one class threading example and one class named counter. Counter only has one field A, and it has method for incrementing that field. So we are trying to initialize counter, then increment that counter 10,000 times, and then at the end we want to see what is the value of that counter. It should be 10,000, right? Okay, let's check it out. So inside we can delete this swagger orientation, we don't need it now, or maybe you can leave it there, doesn't matter really. We want to instantiate our threading example. And what we want to say is we want to call this method to see what will happen. Threading example method. I'll put breakpoint here and I will debug an application. I will also open Postman, and let's try to hit our endpoint send. If we go to this breakpoint, you can see that counter A is 10,000, as expected. Okay, now let's try to spawn multiple threads that will handle this task. Because for now, one thread is handling our request. So if we want to update this 10,000 times, everything is done inside the same CPU. Let's say that we want to make this faster, so we want 5 CPUs, or let's say 2 CPUs, it's enough. We want 2 CPUs to work parallel on this. What we will do? First of all, we need to create our runnable. This is a class from Java lang package. So you can create a runnable as an lambda, and now you can put this for loop inside that runnable. If you try r.run, run is a method on a runnable, you can see it, you should get the same result. This runnable is not explicitly connected with multithreading. Now let's see why we need this runnable. Let's create new thread. So thread from Java lang package, thread1 equals new thread. And thread needs one of the constructors of the thread class accepts runnable. So if we pass our runnable, that is the explanation. What is this thread gonna do? Well, it will execute this runnable in a separate thread, right? It will try to increment this counter. And now we want to start this thread, right? We don't want this air.run. We want to create runnable, what needs to be done, and then we should pass that runnable into thread using constructor dependency injection, right? And then we want to start another thread, thread 2, and we have the same task for thread 2, increment this counter 10,000 times. So when we come here, we should expect to get 20,000, right? Let's check that. Let's go into the debug mode. And now if we try send, okay, we are getting this exception, illegal thread state exception, because you cannot start the same thread twice. And we tried to do that, to start thread 1 2 times. We forgot to put thread 2 here. So let's stop the application and start it in debug again. And now if we try send, take a look at this. Counter, it's 0. This is not executed. Very weird. Okay, the rest of the code we don't care about. Let's try it one more time. Maybe we had some glitch or something. Counter is 0 again. So what's happening here? Pay close attention now. This is not that easy to understand. What's going on? We said that Spring creates one thread for one request. So when our application started handling our request, we have one thread, right? Which is executing this getBooksByAuthorID method. And then inside that thread, we are creating this, we are calling this, we are here, we have one thread, we still have one thread, we just created some task. Then at this point, we created another thread and one more thread. So after this line, we have 3 threads. One thread is executing our method, and those 2 threads, they have their own tasks to do. Now the point is, those 3 threads are doing independently their jobs. So our main thread won't wait for those 2 to finish their job. Our main thread just created a thread, and it's telling to that new thread, start and do your own job. And now new core cares about what's happening in this thread. Our main thread continues doing its own job. Create new thread, start new thread, and we got here, but those 2 threads doesn't even started executing, right? Because you need some small time to spawn up new threads. So we came here even before those 2 threads started executing. That's why our counter is 0. Let's see it just one more time, and then I will explain you how to tell to our main thread to wait for those 2 threads. Okay, one more time. Last time send, we still have 0 here. But if we want to tell to our main thread, hey, please wait for this thread 1 and thread 2 to finish, and only then proceed with your job, you should call join method. Now join method is throwing some exception. You can do throw interrupted exception, and you need to call the same thing, wait this thread and this thread as well. So only after those threads are finished with their job, only then proceed further with your own job. We have a related problem here. We need to throw exception here as well. Let's start our code in the debug mode to see if we solved our problem. Will counter be to 20,000 here? Okay, send. If we take a look here, our counter is, it's not 0, not 20,000, some random number in between. Okay, let's give it one more try, send. Now it's again some number in between, but it's not the same number as before. What's going on here? Why is this number like a random generator now? You encountered a bug that is called race condition, very common bug in multithreading. So basically, pay a close attention what we are doing here. We have two threads, and those two threads are trying in parallel to increment this counter. Let me draw you one diagram. So this counter object is residing in RAM memory, which is heap memory in Java. So let's say that initially counter is 1. So first thread, which is inside some CPU, need to read value of that counter. Let's say it read value of 1. Internally thread increment that value by 1. So now that counter is value of the counter is 2, but that new value is still not written into the RAM memory, right? And then operation number 2 is to write that number to the RAM memory. As you can see, write 2. So, short summary. You have some data on your RAM memory. Operation number 1 is to read that data, then internally processor updates that data by incrementing it, and then operation number 2 is to write that data back, and then counter becomes 2, right? Now let's take a look at the same thing, exact same thing, just with two threads. So you have counter, initial value of counter is 1. So both threads read 1. Thread number 1 read value of 1, thread number 2 read value of 1. Now they are independently increasing that counter. So this thread independently increase value to 2, this thread independently increase value to 2. And then at the end they are trying to write that value of 2 inside our counter. So let's say thread number 2 writes 2, so counter is 2, and then thread number 1 writes 2, but counter is already 2, right? And two threads increased our counter by 1. We started with initial value for counter 1. We would expect that the ending result will be 3 because both threads updated counter by 1, but our result is 2. Notice that CPU 1 don't know what's happening inside CPU 2. So those CPUs, those threads are independent. So what's happening inside thread 2 is not visible to thread 1 and vice versa. And this problem, this race condition problem, is exact reason why this counter A is not 20,000. What you should also notice is that you really need bad timing for this bug to happen. It will happen sometimes and it won't happen in other occurrences. That's why our number here is not constant, it's varying, because sometimes it happens that thread 1 both read and write before thread 2 make read. Sometimes this read happens between those two operations, and so on and so on. That's why the result is not consistent. Now, how to resolve this problem? First of all, you should notice that both reading and writing is happening inside this increment method. This is doing both reading and writing, although it seems like only one operation. It's a little bit of misleading. Let me rewrite this a little bit. So this is the same thing, A equals A plus 1. But now it's slightly more visible. Why is this both read and write operation? Here we are reading value of A, previous value of A. Then we are doing incrementing, and then we are writing that data on the right side of the assigning operator. So then we are writing that to this field. So here we are reading, then we are internally inside our thread updating our value, and then we are writing that to the RAM memory. Now we can put synchronized keyword here on our method. What is this synchronized doing? Well, notice that we put synchronized on the increment method inside counter class, which means that at the same time only one thread can call increment method on the same object. So on the object counter, this object, only one thread at the same time can call this increment method. In the case, let's say that thread 1 called increment method and thread 2 tried to invoke increment method and thread 1 is still not done. Thread 2 in that case will wait. Thread 2 will wait for thread 1 to finish, and only then thread 2 will successfully invoke increment method. And this increment covers both reading and writing. And now, when you know that, if you think again about our problem, this read cannot happen between this read and this write. Let me repeat again. This reading of one thread cannot happen between read and write of another thread, because this read and write both happens inside increment method. Now if we try our endpoint, we will see that every single time our counter will be 20,000. So now we don't have race condition, now we don't have a bug. Let's summarize. So we had a problem that two threads were changing some data in some RAM memory, mutating data. So that means that our data was mutable. So our counter, we were able to change data inside our counter because our counter is mutable. Can we make our counter immutable so we cannot change data? Because sometimes we want to exchange some data between threads, but we want to make sure that we don't introduce bug by mutating data. For that, we need immutable structures, and in the next video, let's see how to create those structures. Before ending this video, I just want to say that in this particular playlist for the beginners, we won't cover more of multithreading because multithreading is not that beginner friendly, and beginners really need some other topics other than multithreading. On the other hand, if you really want to learn more about multithreading, feel free to buy Java Concurrency in Practice book. That book is the best on the multithreading topic. Also, I have a course regarding multithreading, mentoring course, something very similar to this Java backend developer course. So if you want to enroll that course, feel free to write me and we will see what we can do about that. See you in the next video where we will learn about immutability. Bye bye.